We're going to review some trigonometry word problems. These are most commonly encountered on the ACT. We're going to have a couple of lessons where we just review those so you are well practiced on those. This is the one time in our trigonometry work that our angle measures are going to be in degree, not in radian. So get your calculator because these are going to be calculator active problems. And make sure that you are in degree mode on your calculator. There is a mode button on your calculator. Press it. If it's a TI model, then the third row down, you'll be able to choose between radian measure or degree measure. So make sure that you select degree measure on your calculator for working these problems. So there are two types of angles in the setup of these problems that we need to work with. There is an angle of elevation, which is the angle measure goes up from the horizontal, or there is an angle of depression. The angle measure goes down from the horizontal. And we pick that up from the words that are given to us in the trig word problem. So we're going to draw a picture and we're going to pay close attention as to whether our angle is up from the horizontal or the horizon, or whether the angle is down from the horizontal or the horizon. So for instance, if we had this setup and we are standing at the top of this lighthouse and we are talking about what's happening as far as the sun is concerned, which is above where we are standing, that is an angle of elevation. That is measuring up from the horizontal of the object of where we are. If we are in the same lighthouse situation and we are talking about what's happening down here on the water, then that angle from the horizontal of where we are is an angle of depression. So again, from the words in our problem, from the setup of our problem, we'll be able to determine whether we are going up from the horizontal or down from the horizontal, so that we'll know how to draw our right triangle, because that frankly is all that we're after. We're after being able to draw a right triangle, label the information that they gave us in the word problem, and then use a trig relationship, either sine, cosine, or tangent, to solve for the unknown. Sometimes it's the length of a side, sometimes it's an angle measure. So this says, suppose the angle of depression from a lighthouse to a sailboat is 5.7 degrees. If the lighthouse is 150 foot tall, how far away is the sailboat? So again, we want to construct a right triangle. We know that we are dealing with an angle of depression. Our angle is 5.7 degrees. The height vertically is 150 feet, and it's asking for the horizontal distance between the sailboat and the lighthouse. So we're always looking to draw a right triangle. So we're going to set up the triangle. We're going to label the triangle, and then we're going to look for the relationship that is going to help us solve for our unknown. And it's all based on the angle. We're going to start looking at the angle, and we're going to see what sides they gave us so that we'll know which trig ratio to use. Here, from the angle, I have the opposite side length, and they're asking for the adjacent side length. So opposite and adjacent, as far as the angle measure is concerned, that's tangent. Tangent is opposite over adjacent. So I know that the tangent of 5.7 degrees must equal 150 over x. It must equal opposite over adjacent. So I'm going to put those values into an equation, and then I'm going to solve for the unknown. Here they want the side length x. Now, make sure you're in degree mode, and when we put these trig functions into our calculator, we're always going to show at least 4 decimal places for our trig function, and that allows for any error for when we show our answer. If our answer has to be accurate to 3 decimal places, then we will definitely be accurate to 3 decimal places if the pieces that we use are accurate to 4 decimal places. So that's what we're going to do for these homeworks, is when we find our trig value using our calculator, we're going to list 4 decimal places and then do the work to get the answer. So here, 150 divided by 0.0998, which is the tangent of 5.7 degrees, is approximately 1,503 feet. Remember, when they ask in words, we answer in words. So your answers on these should be a well-written statement, just a short one, that makes good sense according to what they ask and is grammatically correct. So let's do another example. Here is an example of river width. A surveyor is measuring a river's width. He uses a tree and a big rock that are on the edge of the river on opposite sides. So there's a tree, there's a big rock, they're on opposite sides of the river. After turning through a 90-degree angle at the big rock, so we go here, he turns at a 90-degree angle at the big rock, he walks 100 meters away to his tent. So we know this distance is 100 meters. He finds the angle from the path that he was walking to the tree opposite the river is 25 degrees. So we know this angle measure is 25 degrees. What is the width of the river? So we want this vertical distance right here. Now, as far as labeling your right triangles, you can just use what makes sense to you. Here we could use W for width instead of D for distance. We could use R for river. So what you choose to use to label your right triangle may not be the same as what I would choose or what your neighbor would choose, but it doesn't matter. Just make sure whatever you choose makes sense according to what they're asking you to do. So we've drawn our diagram, we've labeled everything correctly. So now let's set up our equation. So again, everything starts with the angle. We're looking to see what we have according to the angle. Well, we have the opposite side and we have the adjacent side. So again, we're going to use tangent. So the tangent of 25 degrees must equal opposite over adjacent. So there's my equation, and there is the unknown variable that I need to solve for. So we multiply 100 by both sides. We plug the tangent of 25 degrees into our calculator, multiply that by 100, and the width of the river is 46.63 meters. So these are really straightforward problems, the kind that you're going to encounter on ACT, but I just wanted us to kind of review these a little bit. The DuPont Circle Metro Rail Station in Washington, D.C. has an escalator which carries passengers from the underground tunnel to the street above. So if I'm in the underground tunnel and I'm going to the street above, I'm going to have an angle of elevation. If the angle of elevation of the escalator is 52 degrees and a passenger rides the escalator for 188 feet, find the vertical distance between the tunnel and the street. In other words, how far below the street is the tunnel? So here is our picture. We have an angle of elevation of 52 degrees from the tunnel. We travel 188 feet up to the surface. And so we want to know the vertical height between the tunnel and the street. So now, again, we're going to go to our angle. We're going to see what side measures we have so we can determine what trig function we're going to use. And according to the angle, we need the opposite side and the hypotenuse. So the trig function that is opposite over hypotenuse is sine. So for this problem, we're going to use the sine of 52 degrees. And that has to equal opposite over hypotenuse. Again, we're just going to set up the equation, solve for the unknown, using our calculator, reporting our trig function accurate to 4 decimal places, and then answering in a sentence. So the tunnel is 148.15 feet below the street. So one more final example. A spire sits on top of the top floor of a building. From a point 500 feet from the base of the building, so that's horizontal distance, the angle of elevation to the top of the building, and that's this green triangle, is 35 degrees. The angle of elevation to the top of the spire, that's the red triangle, is 38 degrees. How tall is the spire? So we want this distance, the difference between this red triangle side and this green triangle side. So here is a picture. Let's label everything. We're going to call the total height of the building and the spire, we'll call it T, total height. We're going to call this distance B for the building height, and we're going to call this distance S for the spire. So S plus B must equal t, and that's where this equation comes from. The total building height is the height of the building plus the height of the spire. So we're calling it t, b, and s. And we want to solve for s. So let's start with what we know. We know we have adjacent according to these angles, and we know we have opposite. So we're definitely using tangent. So the tangent of 38 degrees, this whole angle right here, the tangent of 38 degrees must be opposite t over adjacent 500. So now we have this solved for t. Now let's set up an equation for b. This angle measure is 35 degrees. So the tangent of 35 degrees must equal opposite over adjacent, b over 500. So now we have a value for b. And finally, we're going to go back to what we said a while ago. We know that the total must equal the building, the green triangle height, plus the spire, right? The difference between the total and the building. So we're going to find values for that, and we're going to solve for S. If total equals building plus spire, then spire equals total minus building. So that's what we've done. And we found the tangent of 38 degrees and the tangent of 35 degrees accurate to 4 decimal places. And so the spire is 40.5, or approximately 41 feet in height. So there we go. We've worked several examples, turning the words into right triangles, figuring out which trig function we're going to use. Again, make sure you are in degree mode. Come to class next time and we'll work some of these trig word problems.